Welcome back, mathematicians. Today we're going to be talking about triangles and how we can classify them, and this is the 5th grade math geometry unit. In its most simplest form, it is called a polygon, and the definition of the polygon is a closed figure with some straight sides or lines. So a triangle, because it's made of 3 straight lines and it is closed, it is considered a polygon. And because it has 3 sides, it also has 3 angles. So that was simple, but we need to have a system of classifying them. And how do we classify them? What does it mean by classifying? Well, you know the word classify means to sort them. And we do this all the time with Legos. We do this all the time with shapes and other things at home, socks. Okay, so how do we classify triangles? We do by looking at their angles and also by the side lengths. So before we actually get into classifying triangles, we need to understand some of the vocabulary that is used. And I'm going to start with vocabularies that are relating to angles. So I always like to start with right angle because that is kind of the standard where all of our angles are being measured by. So what is a right angle? Right angle is a 90-degree angle. It's exactly 90 degrees. And a lot of times it is denoted by this small square. Then when I look at an acute angle, what I do is I go back to my right angle and I'm seeing that this right here is 90 degrees. So my acute angle would be any angle that is less than 90. So for example, this angle right here is less than 90, so I call it an acute angle. One way to help me remember that an acute angle is less than 90 is that word cute. I'm going to say, oh, that is so cute. It is cute because it is smaller or less than 90. And when I look at obtuse angle, I do the exact same thing. I compare it to the right angle first, and an obtuse angle would be something that is more than 90. So if I look at the point of where my angle is opened, I can say this angle right here is more than 90 degrees. So some vocabulary for sides would be congruent. The word congruent just means the same lengths. And another word that you may hear sometimes is the word regular. Now, we may not use this for triangles, but since we're talking about polygons, I thought to just kind of throw this word in here. But anytime when you hear of a regular polygon, that means that all of their sides are exactly the same lengths. So in essence, congruent and regular kind of mean the same. So now that we've got those vocabularies for sides and angles down, we can start to classify these triangles or grouping them. I'm going to look at the sides first. So when we look at the sides, we're looking at the measure or the length of each of the sides. As you notice in my first triangle right here, I have these sides right here, and they also gave me these measures. And I'm sorry, I can't draw them exactly, but I just wanted to show you where they are at. And because of that, notice one of the sides is 2 inches, the other is 3 inches, and the other is 4 inches. None of them are the same. And another way that they told me that none of these sides are the same are by using these tick marks. These tick marks are these black lines right here that you see. Notice I have 1 line here, I have 2 lines on the other side, and 3 lines on the other side. That tells me that none of those sides are the same. And when there are no same sides or no congruent sides, we call that triangle scalene. Again, we go back to that vocabulary. Congruent means the same lengths. Then now I'm going to look at my second triangle. My second triangle has 2 sides that are the same lengths. And again, those 2 sides are both 3 inches. Notice they also gave us the ticks to show us that there are 2 of them that are exactly the same amount of ticks. Like this side has 2 ticks, and this side also has the exact amount of ticks. that tells me that those two lengths, whatever they are the exact same measure. And when we have at least two lengths that are congruent, we call those triangles isosceles. The key is the word at least. At least means you can also have more than two congruent sides, okay? And now we look at our third triangle. Notice on all of the sides, the exact number of ticks on each of those lines. That tells us that these three sides right here are exact same lengths. We have three congruent sides, and because they're all the same or equal, we call them equilateral. The key root word is equal. Now we go to the angles side. And how do we group them by their angles? Well, again, we're going to use the definition of angles that we talked about earlier. And we're going to compare everything to 90 degrees. So when we have a 90-degree angle right here, that 90-degree angle is a right angle. So this tells me that this is a right triangle. Notice in every triangle, there are some acute angles. So even though there are two acute angles over here, but because there is that one right angle, this whole entire triangle has become a right triangle. We're going to move on to the next type of triangle. And guess why we call this an acute triangle? Well, we can prove it by comparing the angles to right angle or 90-degree angle. And as you can see, this angle right here is less than 90. And as we notice, all of these angles are less than 90. So they're all acute. Therefore, we can call this an acute triangle. And similarly, I can also do the same for my obtuse or triangle. Well, I look at the angles. I know that in every triangle, there are going to be some acute angles. So these two are acute. So now I'm going to look at my biggest angle right here. And as you can see, this biggest angle is actually more than 90 because I drew my 90 degrees right here. If I was to measure this angle, it should be more than 90 degrees right here. Because there is one angle that is more than 90 degrees angle, this whole triangle right now has just become an obtuse triangle. And you may say, well, that doesn't make sense. There are two acute angles in this one versus one obtuse angle, or it's the same with the right angle. There are two acute angles in this triangle and there's only one right angle. So how does that make that triangle a right angle or an obtuse angle? Popular vote does not work when we're talking about angles. Now we're looking for what's unique.